Normal and general form of equation of line. At the end of this lesson, you will be able to describe general form of equation of line, solve problem based on general form of equation of line. We know that we can represent the equation of line in different forms. In the previous lesson, we had studied about lines and normal form of the equation of line. In this lesson, let's study about the general form of equation of line. We represent the general form of the line equation by ax plus by plus c is equal to 0. Here, a, b and c represent the constant terms. It can be any real numbers. To define any form of equation of line, we need 2 points or a point with a slope. Usually, the general form of equation is not the most useful form. So, it can be reframed in slope-intercept form. Thus, minus a by b represents the slope and minus c by b represents the constant. For example, consider a general form of line 4x minus 2y minus 8 is equal to 0. Now, write this equation as y in terms of x. We get the equation in the form of y is equal to 2x minus 4. If we apply different values to x, we get different values for y. These points can be plotted in the graph and represent the line. Now, let us review an application for general form of equation of line. A doctor measures the temperature of a patient's body who has fever. The actual body temperature is 37 degrees Celsius. However, the body heat may vary when a person is sick. Now, he measures the temperature of the body. To analyze the condition of the patient, he periodically measures the temperature. He is aware that the normal body temperature is 37 Celsius. After some time, the doctor periodically checks the patient's body temperature and represents the temperature graphically. Here, the body temperature is periodically increasing in y with respect to x with the constant body temperature. Now, he derives the increasing temperature at certain points. From the temperature measured graphically, the doctor analyzed that the rate of change of body temperature. We are aware that every straight line is associated with an equation. The general equation of the straight line is ax plus by plus c is equal to 0, where a and b are not 0. We can derive this equation of the straight line in different forms. That are reduction to slope-intercept form, reduction to intercept form, and reduction to normal form. Let us see them one by one briefly. The general equation of line ax plus by plus c is equal to 0. Here, we need to reduce this equation into the form of y is equal to mx plus c. By reducing the given equation in the form of y is equal to mx plus c, we get the equation as shown on the screen. Here, assume that b is not equal to 0. Now, on comparing this equation with y is equal to mx plus c, we get the slope m is equal to minus a by b, that is, coefficient of x by coefficient of y. And we get the y-intercept c is equal to minus c by b, that is, minus of constant term by coefficient of y. Next form is reduction to intercept form. Let us take the equation ax plus by plus c is equal to 0. Here, we need to reduce the equation into the form of x by a plus y by b is equal to 1. By simplifying the above equation, we get ax plus by is equal to minus c. Then, on dividing by minus c on both sides, we get, on further simplification, we get by assuming a and b is not equal to 0. Hence, this is the reduction form of a line. Now, on comparing this equation with slope equation, we get the x-intercept a is equal to minus c by a, that is, minus of constant term by coefficient of x. And we get the y-intercept b is equal to minus c by b, that is, minus of constant term by coefficient of y. Now, let's discuss about reduction to normal form. We know the general form, that is, ax plus by plus c is equal to 0, and its normal form as x cos alpha plus y sin alpha is equal to p. We know that these two equations represent the same line. If we compare both equations, we get a by cos alpha is equal to b by sin alpha is equal to c by minus p. Then, on equating the above terms, to get the value of cos alpha is equal to minus ap by c and sin alpha is equal to minus bp by c. We know that cos square alpha plus sin square alpha is equal to 1. If we substitute the values of cos alpha and sin alpha into this equation, we get minus ap by c whole square plus minus bp by c whole square is equal to 1. By simplifying the equation, we get p square is equal to c square by a square plus b square. Taking square root on both sides, we get p is equal to modulus of c by square root of a square plus b square. Substituting the value of p in cos and sin term, we get. Now, on substituting the value of cos alpha, sin alpha and p value in the equation of normal and simplifying, we get the required reduction form. Let's solve a problem. Reduce the equation x plus root 3y plus 4 is equal to 0 to the following forms: slope-intercept form and find its slope, and y-intercept, intercept form and find its intercepts on the x-axis, normal form and find the values of p and alpha. Solution. From the given equation, we can write the equation of line as y is equal to minus 1 by root 3 into x plus minus 4 by root 3. This equation is in the form of slope-intercept. Therefore, the slope m is equal to minus 1 by root 3 and y-intercept c is equal to minus 4 by root 3. Next, we have to find out intercept form. On taking 4 on right side, we get x plus root 3y is equal to minus 4. On dividing both sides by minus 4, we get x by minus 4 plus root 3y by minus 4 is equal to 1. This implies x by minus 4 plus y by minus 4 by root 3 is equal to 1. This equation is in the form of intercept. By equating the general terms, we get x-intercept a is equal to minus 4 and y-intercept b is equal to minus 4 by root 3. Finally, we find out the normal form. The given equation is Now, on simplifying the equation, we get minus x minus root 3y is equal to 4. Dividing by 2 on both sides, we get minus 1 by 2 into x plus minus of root 3 by 2 into y is equal to 2. Now, we obtain this equation is in the form of normal. By equating the general terms, we get p as 2 and cos alpha is equal to minus 1 by 2, which implies alpha is equal to 120 degrees or 240 degrees. Similarly, we get sin alpha is equal to minus root 3 by 2, which implies alpha is equal to 240 degrees or 300 degrees. In both cos and sine terms, we get the degree 240 commonly. Hence, alpha is 240 degrees. Hence, the required normal form is x cos 240 degrees plus y sin 240 degrees is equal to 2. Summary. Let us summarize what we have learnt. We can derive the equation of the straight line in different forms, such as slope-intersect form, intercept form, and normal form.